here, and sorry about the fire drill. We're back at it. Hopefully I can pick up where I left off. So for the conditional statement, forever, my program is going to check if my sprite, which is Scratch, that's the one I'm in right now, is touching the bat. It's going to say hi for 0.5 seconds. So let's test that out and see if it works. Now the bat spawns in random spots over the screen, so I might kind of have to get lucky and run into it. Oh, look at that, he landed on me right away. So as long as it's not touching me, nothing's happening. But as soon as the bat touches the sprite, it says hit, because that's what I told it to do. And it'll still work if I'm moving around the screen. You'll notice every time I hit the bat, it says bat, or hit, sorry. And we've successfully been able to detect whether or not the bat is going to trigger the desired response, which in this case is Scratch the Cat just saying hit. So that's something we can do that uses both looping and conditional statements, so the forever and the conditional being the if statement. And as well, we're also using input and output, because we're giving Scratch input through the keys, and we're getting output based on what we see when the cat is moving, and also when we hit the bat. So we're using already, three of the 5 fundamental principles of programming that we're going to go into this semester. And while we're at it, we might as well add one more. One of the most important principles is the idea of data, collecting data and storing data, and using variables. So what we're going to do now is we're going to create a variable, which you're going to need for several of those micro assignments. And there's an entire area set for variables down here. So if we click on the dark orange, we have a default set of blocks here, but most of the time when you're creating a variable, you're going to want to make a new one. So I'm going to make a variable, and I'm just going to call this hits. And what we're going to do with this is we're going to keep track of how many times the cat hits the bat, and we're going to display it for the user. So I'm just going to call this hits, and I want this to be accurate for all sprites. Right now, I'm just in the cat sprite, so it actually shouldn't matter if I do either of these, but there are definitely times where you're going to want that variable to work for every single character or every single sprite in your program. So I'm just going to leave that. Usually I leave it for all sprites unless there's a very specific reason not to. And you'll notice as soon as you create a variable, it puts it up in the top corner, and you can toggle that on and off just by hitting this little arrow over here. Okay, so you can toggle that on and off to show it. And we don't have our hits variable doing anything yet. So even though I get a hit with the cat here, it says hit like I told it to, but it doesn't change the number of hits up in the corner. So we've got to add some logic that whenever we get a hit, that it's going to increase that hits column or that hits counter by 1. And that's where these other variables come in. As soon as you create a variable, you can choose that variable with the drop down. So if you have more than one variable, you'll have more than one place where you can change things or set things, and that's what we want. So what we want to do is we want to change the hits by 1 every time the bat is contacted by the cat sprite. And we don't have to build an entire new block for this, because we've really already got it set up. We've already got the conditional set up that if the cat is touching the bat, we're going to say hit, but why don't we also change the hits by 1 each time? So it's kind of doing 2 things within that one conditional statement. If I run into the bat, it's both going to say hit for 0.5 seconds, and it's also going to add to our hits variable. And you should notice that every time I'm running into the bat here, it's adding 1 to this hits variable up top. So, basically in a couple of quick steps, I've added a full nother layer of concept into this program, and now we're using 4 out of the 5 major milestones of programming, or major tenets of programming. We're using input-output, we're using data and data storage, and variables. We're using conditional statements, so if statements, and we're also using looping. So we were really on a very simple program that didn't take very long to build. We've already got 4 of the 5 sort of major concepts in play here. One of the things mentioned yesterday was that we want to make sure that we reset things when we start a program, so that basically everything starts from scratch again. Just like if you're playing a video game or something, and you leave for the day and you come back, you probably want to start from where you. Actually, that's probably not a great analogy, because I guess a lot of the times in video games, you want to pick up where you left off. But let's just say that you want to start again. Say you're playing a game of online billiards or something like that. And you play and you lost a game, and then you want to go try another game. You want to do it again. You don't want to start with the same score or the same layout of the video game that you ended with because you lost, right? You want to start from scratch again, so to speak, from scratch. So, we like to reset everything at the beginning, and our resetting is the first thing you do right underneath this flag. So all we're resetting right now is every time I hit the green flag, Scratch goes to the middle of the screen, Scratch points right. But what I can do is I can also add another thing in there where it says set. Instead of change, this one's going to say set. So I'm going to set hits to 0 so that every time I hit the green flag, it's just going to reset my counter to 0 so I can play a game. Here's my game. There we go. Okay, there I got 5 hits. Great. And now if I stop the game and I start again, Scratch resets position, direction, and then also the hit counter goes back to 0. So I've only got one variable going here right now, but you could have as many variables as you want going at one time. And it's pretty easy to keep track of them if you just do it over here. If you do find that you've got, say you've got some reason that you need to retain similar information, but different numbers, you can use something called a list. And a list is going to allow you to, like make an inventory. If I use the video game analogy again, maybe maybe you're a character and you can pick up things along the way. So maybe you pick up a sword and a shield or some food or an elixir or something like that. Instead of your variable just changing to whatever it is you just picked up, you can keep a list of things and say, I don't just have one item, I've got 5 items. And then you can find ways to select which item you want to use. If I press S, maybe it brings up my sword. If I press E, maybe it heals me with an elixir or something like that. So it's using like RPG elements here, which you may or may not be familiar with. The idea is you've got a list of different items that you can cycle through and you can pick based on your input or where you are in the screen or if you're about to come into battle or something like that. So variables and lists work in a similar way. They're just storage vehicles for some sort of data. We're not going to go into lists too much. You will get a little practice with that with the micro assignments. There's one where the cat's stealing stuff or taking stuff, so that'll help you with that. But now that we know how to do that, we need to move on to one more principle. And just checking on my list here, which is broadcasting. Broadcasting is kind of a big one. One of your bigger assignments in the first, or one of your bigger programs in the first assignment is one called I'm Ron Burgundy, because he's a broadcaster in the movie. And what you need to do is you need to actually ask a user some information. So you need to ask a user, do you want me to draw a square or a triangle? So you've got to get that data first. And then using that data, you've got to somehow make a decision or branch it so that if the cat is supposed to draw a square, it goes one way, and if it's supposed to draw a triangle, it goes the other way. So you've got a decision there, but you've also got 2 different routes you can go and 2 different things you need to draw. Now, you could do this with just a bunch of if statements, but I want to make sure that we know how to broadcast, because when you broadcast something, it's like sending a signal out to the entire program saying, this happened. It's not just that one sprite. You send the radio signal out to your entire program, and any character or sprite in the program can see that and can use that. And if that sounds a bit confusing, I think it'll make it a lot simpler if we just do a quick example here. We're going to broadcast something once the number of hits gets to 10. So I'm going to throw another. I could put this in one of these blocks, but just to keep things nice and organized, I'm going to throw a third block into Mr. or Ms. Scratch the Cat. And what this is going to do is it's going to forever. I mean, a lot of the times you need to have forever in here. Otherwise, it'll just check something once at the beginning of the program, and it won't check it again. So I need to have a forever loop in here so that it continually checks as long as the program is running. And what we're going to check is, do we have, let's call it 15 hits. So I need to check something. I've got a condition, which means I need to have some sort of if statement in there. So I'm just going to bring my if statement out there and throw it in my forever. And now I have to decide, what is it I'm checking? What's the condition? Well, the condition is, do we have 15 hits? And in order to do this, we've got to go down to the math or operators area so that we can do a comparison. So we look in the operators area here. You'll notice you got all the math symbols. You got plus, minus. The asterisk or star is multiplication, and the slash is division. We've already seen the random. We know for math greater than, less than, equal to. And equal to is the one that we want, because we want to check if the number of hits is equal to not 50, but in this case, I think I said 15. So this other box here is where we can put the variable, and you can just, you'll notice, I mean, the things that are shaped appropriately, so it helps you know what you need to put into each one of these blocks. You'll notice I'm looking for something that's round, and my hits variable up here is round, so I just drag that in here. What I check is, are hits equal to 15? So I'll throw that in as my condition, and if hits are equal to 15, I want to broadcast something. So broadcasting is up here in the events file, and it's just a little further down, and you'll notice that there's a couple broadcasts down here. One is broadcast and one is broadcast and wait. So if you want your program to kind of freeze and stop while the broadcast is sent out, you can use the wait. Most of the time I just use broadcast. Now there's a default message in here. It just says message 1. Well, we don't have a message yet. We haven't made one. So I'm going to go to new message. And you name these appropriately. Let's say the game is over when you get 15 hits and you win. So I'm maybe just going to call this message win. So when I say you're broadcasting a message, I don't mean that the cat's going to say something or that there's going to be a message popping up on the screen. All I'm saying is that behind the scenes, behind what's going on in the program, when the 15 hits is reached, it's going to broadcast something behind the scenes that every sprite can pick up, just like a radio station. That's why it's called a broadcast. And if the broadcast is win, I can have something happen based on that broadcast. And I can have it in the same sprite. So I could have it in the cat sprite, or I could also have it in the bat sprite. Now, I probably should put it in the cat sprite, but I'm just to demonstrate that you can put it in a different sprite. I'm going to go over to the bat. We don't have a whole lot of stuff in the bat here. All we've got is a way for it to appear randomly and change placement, and for it to switch costumes so it looks like the wings are flapping. But I'm going to add in something where I receive that broadcast. So when you send a broadcast, you can have whichever sprite you want receive a broadcast as well. So that's this one right here. So when I receive, and then there's the list of messages, and we've only got one in there right now, win. So when I receive win, we can have something happen. And in this case, maybe I'll just have the bat say you won. So if I go up to looks, I'll have the bat say you got me for 2 seconds. What's going to happen here, and this is sort of just the little odds and ends, the little details you fix up at the end. I can already anticipate what's going to happen. When this happens and when you get 15 hits, after the message, you got me for 2 seconds, the program's still going to continue because I didn't tell it to stop. So if we run the program right now, and because I got a hit there, so I'll try and get up to 15 hits. I'm at 4, 8, 9, 10, 11, 12, 13, 14, 15. Okay, so I got 15, and then you see the bat is saying, you got me for 2 seconds. So what actually happened behind the scenes there was it's running all these blocks, so these 3 big containers, it's running all at the same time, doing different things, but at the same time. And one of those things it's checking continually is, do we have 15 hits? And as soon as we got to the point where our hits equaled 15, okay, our sprite sent out, or the program sent out a broadcast saying, ooh, we hit 15. So I sent out a message to every other sprite saying, win, 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 win. And what happened was the bat picked up that broadcast. So they got it on their radio and said, oh, as soon as I receive the win broadcast, I'm supposed to say, you got me for 2 seconds. So that did happen, but you'll notice the program didn't end because I'm still getting hits adding up. I can still move my cats, the bat's still moving around. So if this were truly the end of the game, you'd want to have some way to do something else, change a level, or the game's over and display a congratulations message or something like that. In this case, I'll just end the program, and I can do that by going to, I was clicking on the wrong screen here, by going to the control blocks, and there's one that says stop. And you could stop just the sprite, and it says this script, okay, which is just this little box. It says other scripts, which means all the boxes, and then it says all. Usually you're just going to use all. What stop all does means it stops everything in this sprite as well as other sprites. So it will stop the cat from moving as well. So let's just test that out and see if it works. So I stop it, okay, and I hit go, and we try again. When we get to 15, we should get the bat message saying you got me. And then as soon as that 2 seconds is up, the program should just stop and end. Okay, so it says you got me for 2 seconds, and now you notice the program end, everything froze, and I can't do anything because the program's over. It did allow a couple more hits because as the bat was saying you got me for 2 seconds, the cat was still touching it, so it was still adding to it. And you can take care of that in multiple ways. I mean, a lot of this is just sort of playing around with it to get it exactly the way you want it to go. If I wanted to sort of fix that little bug where it says, where the hits keep going up, down here, oops, again, wrong screen. Down here, before I stop everything, I could just do something like set hits to 15. And then stop instantly. So what that'll do is it'll reset the score to 15, which is what the ending score will be, and then it stops everything. So ideally, if this is going to work, when I hit the bat 15 times, as soon as that happens, it's going to reset hits to 15. And I can actually already see a bit of a logic error in my program, but I'll show you what it is. 12. 13, 14, 15. You got me. But you notice the hits are still going up, but now it goes back down to 15. That's just the order in which I have things. So I've got the bat saying you got me for 2 seconds before it sets the hits to 15. So if I just swap those two around, it'll just do it in the other order, right? As soon as we get win, it'll set hits to 15 instantly. And then it'll say you got me for 2 seconds, and then it'll stop all. The question I have is, if it sets hits to 15 and then says this for 2 seconds, is it going to continue to collect hits while it's doing this? And it might actually very well do that. There's always a workaround for this sort of stuff, but right now, I think for simplicity's sake, I might just, instead of setting hits to 15, I might just hide the variable as soon as I get to 15. So we don't see it going to 16, 17, 18. And the only thing you'll see is the bat saying, game over, you got me. So let's try this again. We should have made it less than 15. Getting close. Okay, 15. And then you notice that the hits variable disappeared. The bat says, you got me for 2 seconds. And then the program should be stopping here, but for some reason it's not. And I think that might just be a bug for some reason, because it was continuing to do that for longer than 2 seconds. It appeared, but the logic is fine though. It says hide variable hits. It clearly did that. It said you got me. Instead of for doing it for 2 seconds, it did it for like 10 seconds. And I'm actually not sure why it did that, because the logic does not tell it to do that. I'll just test that one more time to see if it's kind of a one-time thing or if it's a bug. And sometimes there's things in Scratch that, despite your logic, just don't work the way you want it to. But usually it's just sort of one-time glitches. And as you can see, that time the bat said you got me for 2 seconds, and then things did indeed stop right away. So I think that was just a one-time glitch. But the logic works. So in that most recent example there, I showed you how you can broadcast things, how you can use your variables to have sprites, either the sprite you're in or a different sprite, do something or say something by basically broadcasting a message saying, whatever, win, lose, tie. And then when something receives that message, if you program the bat to receive a message, which we did, then you can get the bat to do certain things, and you can stop programs or pause or do whatever you need, update scores, could call it a win, call it a loss. And it's really handy. It's a really handy way to move across sprites with information and have them detect things. In say games or programs where you have multiple sprites acting in a similar manner, you can duplicate sprites down here just by right-clicking and hitting duplicate. And what happens is it just creates a new version of whatever it is you wanted to duplicate, and it takes all the programming code with it. So whatever I did in the original bat, when I duplicate it, it goes to a new bat. And you can duplicate things as many times as you want. But here's something that I kind of caution you on, and that is if you make changes to the code in the original, it does not automatically go to the copies of it. Okay, if you create a clone, it will, but if you just right-click duplicate, it won't. So if you are going to have multiple sprites doing similar things on a screen, make sure you get it working perfectly once and then duplicate. Don't duplicate it right at the beginning, because then you're just going to have to copy the code and redo the code for all the new ones. So if you have multiple things that are very similar and have similar features and similar functions, wait till the end and make sure one's working perfectly before you duplicate. And I say that because one of your larger projects in the next assignment is to create a raindrop game whereby raindrops randomly appear at the top of the screen and fall to the ground and then are respawned at the top, and they're all falling at different speeds, and they're all falling at different in different areas of the screen. So they all operate the same way. They all appear in a random spot. They all fall. They all hit the ground, and there's logic built in for what happens when a raindrop hits. Basically, it's a sprite with an umbrella or something. So there's functionality built into all of these raindrops, and maybe there's 25 raindrops, but the functionality is exactly the same for each one. So what you wouldn't want to do is create 25 raindrops and then program each of the 25 raindrops. What you'd want to do is you'd want to program one raindrop, make sure that one raindrop is working perfectly with your program and the logic all works, and whatever you need to do is working properly. And then you duplicate that 24 more times because you've got it working properly first. So now we're just going to make a whole bunch more, and they should all work the same way. And of course, it's going to happen where you think you've got it programmed perfectly and you duplicate it a whole bunch of times and you realize, I forgot to do something, or I need to change something. Well, then you just got to go and delete the old 24 and then fix what it is in the one you want to work and then duplicate them again. So it will happen. I'm not going to lie to you, but you can save yourself some headache if you get the one thing working properly first before you do the others. So in copying these bats, maybe I'll just throw a few more out there. Duplicate. So I've got 4 bats out there right now. They're all programmed the exact same way. So all of the bats are going to flap their wings. All of the bats are going to appear in a random location every 2 seconds. And they're all going to detect hits and say, you got me, if the game is over. So let's just, I'll go to big screen now. And okay, so I've all got bats and they're all appearing in a random spot. The problem is they're all appearing at the same time. You know, you could stagger it by putting a weight in there so that they kind of dot all over the place instead of all flashing off and then flashing on and then flashing off and flashing on. You can just use a weight. You can just use a random weight for each bird or for each bat so that it'll appear at a random time. My game, I'm not sure what happened to my hits variable there. I gotta check that again. Oh, actually, I forgot one important thing with regard to when I hid the variable for hits, it remains hidden until you tell it to come back. So when I go to my cat, my scratch, sort of the main sprite in the program, and I'm resetting things at the beginning. That's just one more thing I need to add to reset, right? So I hid hits. So what I need to do is I need to make sure that I'm showing hits right at the beginning. So the very first 4 things my program does: move scratch to the middle, point scratch toward the right, make sure that the variable hits is showing on the screen, and then sets hits to 0. So that when my program ends and it hides my hits variable, when I start the program up again, it remembers to put the hits variable back up there, or hits display. So if I hit start now, you'll notice it's back up there. Should be detecting hits. Not sure why. There you go. And the more stuff, Scratch is based on, it's web architecture. Sometimes it's a little slow. It's not like a heavily optimized graphical video games creation system or anything like that. So you may have things programmed perfectly, but you'll notice that your character isn't moving very quickly, or sometimes things randomly slow down. That's just Scratch shortcoming. It's not necessarily bad programming. But it looked like it worked fine there. My hits were going up every time I hit a bat. It didn't matter which bat I hit. The bats were all moving around the screen, like randomly appearing in different locations. And then when I got my 15 hits, all of the bats said, you got me. Probably should have said, you got us. And then the score disappeared like I asked it to. So it appeared to be working properly there. And I had mentioned that I'm just going to delete these. I had mentioned that you can have the bats appearing at random intervals instead of having them all on or all off at the same time. And I'll just throw that into the bat sprite here, just so that we are completely clear on what I meant by that. So if I have a bat and I want the bat to change the position, what I can just do is I can put a random weight in, random weight. So if I go to my weight feature, which is, find my weight here, there it is, right at the top of control. So if I wait a random amount of time, that means the bats will randomly be disappearing and appearing in different spots instead of all flashing on, flashing off. So I'll just go back down to my random, and instead of waiting 1 second, I'll pick a random between 1 and 4 seconds. So every time a bat respawns, maybe I'll make it 2. Is that gonna be enough? Maybe I'll make it 0.22, 2 seconds. So every time my bat respawns somewhere, I put it inside the forever loop, it's going to wait a random period of time between 0.2 seconds and 2 seconds before it puts it in a random location. So ideally, if this has worked properly, and because I made a change to one bat, I deleted the other bats. Now I'm going to go back and I'm going to duplicate them again. Okay, this is what I mean when, every time you make a change, you got to go back and change things again. Okay, so I've got my 4 bats on the screen, and now because I put a random wait time in for each of them, they should kind of be appearing and disappearing in random time. So you see now they are randomly kind of clicking around, and that wait time is going to be anywhere from 0.2 seconds, which is almost instantaneous, to 2 seconds, I said. And now I just play the game, and it doesn't look quite so, I don't know, predictable, because the bats are actually appearing and disappearing at different times and appearing and disappearing in different places. And if I get up to 15 hits somehow, my touch logic is a little faulty here. Oh, I got it. Okay, so they all say you got me. They're still kind of flying around the screen, and then after that 2-second message is done, then the program is over, because I told it to stop after the 2 seconds where it says you got me. Okay, so that's what I meant just by putting in, you can use that random feature in a lot of different places. You can generate random numbers for time. You can generate random numbers for variables. Maybe you've got a dice game or something. You can generate a random dice roll between 1 and 6 or something like that. So that random is quite a handy little operator feature there, and you can use it. So if I look at my list of what I wanted to get through today, we've discussed broadcasting, how to send a broadcast, how to receive a broadcast. We've done variables. When it says initializing, it's just initializing variables just means setting them to 0 and resetting the program. So if you've never seen the word initialization before, just means the initial setup, which means you basically you set everything up at the beginning of the program, so that every time you reset the program, all the values for your variables and positions and things like that go back to the regular starting position, so things don't just kind of start all over the place. If you didn't do that and we played the game we just played, the next time you tried to play, your hits would already be at 15, so the bats would all just say, you got me right away, and the game would be over before you even started. Augmenting just means adding to. So we did augmenting in the sense that every time you hit a bat, it added 1 to the hits variable, which just meant augmenting the hits variable. In computer science, the 2 terms you'll see for this are incrementing and decrementing. So that's just the terminology you're going to see in the industry. Incrementing means adding to, and decrementing means taking away from. So if I say increment your values by 5, that means add 5 to your values. If I say decrement your value by 1, it means take 1 away. So augmenting, it just means adding to. But really the 2 words that you probably should be more familiar with are incrementing to add and decrementing to subtract. There is math in this class, but I mean, by and large, the math is relatively simple. The hard part is not the math and knowing how to do math. That's what we got computers for. The hard part is structuring your logic and building your program in a way that you can get the computer to do the right math at the right time and give you the right result. And so the challenge is in programming, not in the doing the math. You're not going to be factoring quadratics in your actual code. And we have machines for that. I didn't discuss functions or mini programs in a larger program. That comes into play a lot more in your reboard unit. But if we just have a quick look at our Scratch game, you can build your own functions. And you can build your own functions down here in my blocks. So they're called blocks instead of functions, but you can essentially create custom blocks. And we've been using all these blocks that are built in, but you can actually create a custom block and have it do a whole bunch of different things based on what your logic is. You don't have to use that in any part of the Scratch assignments that I've given you for this course, but oftentimes for final project, students will choose to do a Scratch project, and I insist that they create their own blocks because it's one of the 5 major concepts that we have to cover. So just letting you know it's there. The Burgundy assignment requires you to use the pen. Unfortunately, the pen is not one of the default block areas here. So I do have a little video or explain a little piece that explains how to do this, but I'll just do it quickly here. You can add custom features down here. So there are lots more tools that are built for Scratch that they don't have on the main bar. If you go down to add extension, there's all of these extensions, and one of them is drawing or the pen. So you basically just have to go click that pen, and now you notice there's a pen thing here. And what the pen allows you to do is you can attach it to a sprite. And as you can put the pen down and then move, and it'll draw something, and you can pick the pen up, and then it'll stop drawing something. So for instance, let's just say if I want them to draw a line, if we go to the right, so inside the part where it says, if right arrow key, press blah, 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 I'll put the pen down. Okay. And then as he moves, because the pen's down, it does it automatically. As he moves, it's going to draw a line behind, right? And maybe if I go left, maybe I pick the pen up. So basically it'll draw until the pen is picked up. So if I go to the right, it's going to put the pen down, it's going to draw, and then because the pen's down, I think it's going to continue to do it for up and down. But then as soon as I hit left, it's going to pick the pen up. So let's just check and see how that works. And so if I go to the right, pen should go down, and you see I'm drawing, and then as soon as I went to the left, it picked the pen up. So if I go to the right again, I didn't. Every time you add something to your program, you're going to notice, oh man, now I got to go back and change the default. Okay, so at the beginning, when we're initializing all our things here, we should also add in a pick pen, an erase all, and then maybe pen up, just to make sure that the pen is not on the paper when you start your program. So if I go back and do it again, now the line will disappear because I told it to erase. If I go to the right, it draws a line. The pen's still down, so it's still drawing when I go up and down and right. But as soon as I hit left, it picks up the pen, and I'm done drawing. Okay. As soon as I hit right, pen goes down again, and then every time I hit left, the pen is picked up. And then when I end my program and start again, it erases everything, and it puts the pen away. So you'll notice if I go up and down, I don't have the pen. I have to go right to access the pen. And then as soon as I go left, the pen is gone. And then I access right, the pen's on again, off again, on again, off again. I think you get the point. You'll find that you start out with very few of these sort of initialization things, tasks that you have to do at the very start of a program. And then as you add functionality to your program, you have to add things to the front saying, oh, okay, well, I added a pen, which means if I want to start a new program, I got to get rid of all the old pen marks, and I got to put the pen up off the paper again. I have to make sure that I reset my direction. I have to reset my starting point. I have to reset my hits variable. I got to set my hits variable to 0. That's resetting my hits variable, and I have to show my hit variable. So at the end of the day, we started out with, I think, none of these, and we ended up with 1, 2, 3, 4, 5, 6 initialization exercises. So 6 things that Scratch has to do every time it starts the program again. Otherwise, I'm going to have clutter and crap left over from the last time I ran the program. So that should give you that's a reasonably comprehensive tutorial over the last 2 days of what you can do in Scratch, and you can use the skills that we went through here to complete all of the assignments in Scratch. The assignments, the 2 larger programs, rock, paper, scissors, and raindrops, or Raincatcher, whatever I called it, are a little bit more complex and require multiple sprites and require broadcasting, but you should be practicing those skills as you do the smaller assignments in the first Scratch, or the small projects in the first Scratch assignment. And then by the time you get to rock, paper, scissors and the Raincatcher one, you'll probably have 80% of the skills pretty dialed in that you need, and then you're going to have to explore a little bit and practice and maybe use reference material on the web or come back to these videos that I did to make sure that you're using broadcasting properly and that you're using your variables properly and that you know how to add to scores and subtract from scores and reset things. But the information is there. I'm just saying the first 4 or 5 little programs in Scratch are quite simple. A lot of them I give you a Scratch file and then you just have to open it and fix it. Others you have to start from the beginning and build it all yourself. And then for the 2 bigger projects, you have to start those all by yourself, build them all by yourself, and make sure that they function properly all by yourself. And that's what I got for today and for Scratch. Are there any questions? And I'll keep these files handy and I'll post them on the website so that if you're trying to replicate what I'm doing here while going along with the tutorial, you can use the file I had, or you can see the blocks I had inside my file and play around with them. I'm not seeing or hearing any questions, so have a wonderful day. I think our next meeting is scheduled for Friday, and I look forward to seeing you there. Take care.